So today I'm building a 40 amp hour lithium iron phosphate battery out of prismatic cells. Let's have a look on the website, see what's currently available. So here I'm on the battery hookup website, and currently they have a lot of inventory. And if you use my discount code Simplicity, you get 5% off your purchase. And if you scroll down to the lithium iron phosphate section right here, you can see a lot of these prismatic cells are in stock right now. That's very unusual. They're usually pretty hard to come by. And they go from 40 amps all the way up to 180 amp hours. So you can choose the capacity you want, and you can configure the battery the way you want it to. And if you don't want to build it, look at this. They even have completely finished batteries. And here's one 40 amp hour battery for $85 completely built. So I got a shipment in from Battery Hookup, and I'll leave all the links in the description for you. Let's see what's in here. Oh, looks like prismatic lithium iron phosphate cells. So first things first, let's check the voltage of each cell. It should be resting at 3.3, so this is 3.28, 3.28, 3.28, 3.28, 327, 328. So the first thing I want to do is I want to top balance these. I think the voltages are okay to connect in parallel. Yeah, I'm not making any changes to it. So first thing I got to do is I got to build some bus bars to connect all the negatives together here and all the positives together. So this is the aluminum flat bar that I'm going to use, and I'm just gonna measure it across these poles here and cut it off, drill some holes, and those are going to be my bus bars. Yeah, a quick deburr on my belt sander here. I'm gonna mark a center line on these, so these are 1 inch, if I'm not mistaken. Yep, 1 inch. So I'll cut this to 0.5 inches, and then just scribe a center line on it. I just eyeball it. I just mark where I need to drill the holes, and that'll do it. So once your bus bars are made, you want to connect all the positives and all the negative terminals together. And currently we're only dealing with this battery. It's going to be a 4S battery. The voltage difference was only 0.1 volts, so it's safe to connect them in parallel. At this point, you would think these battery cells would balance the voltage, but in case of lithium, they don't. So you really got to charge them to full voltage. So this is technically a 1S battery, right? Because all of them are in parallel, and each cell is 40 amps. So you have 4, 8, 160. This is a 160 amp hour battery at 3.65 maximum voltage. So I guess I'm using this power supply here. Let me see if I can get 3.65 volts dialed in. These power supplies are a little touchy, but 3 point, and I probably need, actually I'm gonna go in with 4 volts. The reason is I may be charging with 4 volts, but the battery never sees 4 volts because the current goes directly into the cells. And actually the spec sheet on this battery says you can charge with 4 volts. So that's dialed in. Get your leads on here. I like to use the middle of the bus bar, but in case of bus bars, I don't think it really matters if you hook it up to the end or to the middle. But it's just good practice once you build larger batteries. Okay, I'm currently charging with 4 amps, which is not a whole lot. Let me bump this voltage up a little bit. Oh, it's limited by the current, which is good. Let's crank up the current. Oh yeah, look at this. This power supply supplies 10 amps it says, but man, these wires are really thin for 10 amps, but I'm gonna give it 10 amps. Here my voltage is a little high. So stay below 4 volts for charging on lithium iron phosphate, and then amps, you know, whatever it takes. Yeah, amps are all the way cranked up. So currently the battery takes 8.6 amps, and I'm gonna leave this on here. Ideally, you would leave it on for a few hours, but I have a couple of friends coming over and we would want to build this battery. So it's probably gonna stay on here for about maybe 45 minutes, and then we check the voltage. And these batteries are almost fully charged, so maybe that's all we need. Okay, it's the next day now, and we ended up building a battery yesterday. But let's focus on the one that we are currently building. So I charged this battery last night all the way up to 3.6 volts, connected in parallel. So now I'm going to take the bus bars off and check the voltage of each cell, and I'm pretty sure it's exactly 3.6. And then we can start assembling this thing. Check the voltage here real quick. 3.43, 3.43, 3.43, 3.43. As expected, battery is completely balanced and top balanced and charged. So now the configuration, of course, has to be positive to negative, and then positive to negative to put it into a 4S configuration. So this can be my main negative, and then it goes through the battery to the positive. A bus bar goes here, through the battery to this positive. Bus bar goes here, through the battery to this positive. A bus bar goes here, so this is going to be my main positive. So I got to cut these bus bars in half and start assembling this thing. All right, you know what, let's turn this thing around. Okay, I want this to be my main negative. It's just the way I built them. Okay, so these two get connected. Main negative through the battery to this positive, positive to negative through the battery, this positive to this negative. At this point you want to be careful not to shorten out the battery because it will spark on you and it'll be fireworks. So be very careful with your bus bars and your tools. Another reason I like this wrench versus just a mechanical, spanner, because if you have a spanner, it's very likely you're going to shorten this thing out at some point. So, okay, last one through the battery. These two guys. Just snug for now because we have to take them off again and put ring terminals on it, as we assemble the battery. And if we did everything correctly, we should have, 14.4 volts, something like that. Let's see here. Positive, negative. Yeah, 13.7 volts, so good. So this is a battery management system here. You got to make sure it's the right voltage for lithium iron phosphate. And this one has a discharge current of 30 amps and a charge current of 20 amps. And it has a balancing feature as well. So let's open this up. So let's take a look at the BMS here. So this says B minus on it and this says C minus on it. So B minus is your main battery negative, which in our case is right here. And that's why I like to have my negative pole on that side, because I'm going to mount the BMS on the opposite side right here. And then I can run a short conductor directly to the battery negative, and all my balance leads can go to the individual cells. This one. And of course you got to tin your conductor. And these guys go forward. Just apply some heat and it should. There you go. Trim off the excess. Nice and flush. Looks pretty good. This end gets a ring terminal because this goes straight to the battery. And then this longer end gets an Anderson connector on it. So I'm using these blue ring terminals because the battery is only rated for 20 amps anyway. I pull these insulators off. I think it just looks a little better that way. So these are crimped on, and I also solder the ends. Looks pretty good. So at this point we can see how to mount the BMS, and the length or the position of the BMS is determined now by the length of this conductor here. So this is my main negative. So what I do, you loosely attach it for now so that you can position the BMS where it needs to go. There you go. And then, well, it's a hair long, but I'll leave it. So the BMS sits pretty low, so I'll just use double-sided tape on the back. I'll leave a link in the description for you. So this foam tape is really good. It's like super sticky. So I flip the battery over so that I can work with it a little bit better. And then just put 2 pieces of double-sided tape on the back. Make sure it all looks good. Okay. So this is the position of the BMS. I'm going to put an Anderson on this, so this is going to be my negative. So only the negative goes through the battery management system, and the positive you can run directly from the positive terminal here. So at this point I have to tie these battery cells together, and I'm using this, they call it captain's tape. It doesn't stretch, it's like super strong tape. So at this point the battery has pretty good integrity. So at this point I'm running my positive wire with a ring terminal up, over, and I want to combine it with my negative. And up here just going to use a zip tie. Yeah, that's what that looks like. And then these are my positive and negative leads for the battery. I'm going to trim these to length, put some heat shrink tubing on it in certain intervals, and then put Andersons on it. Okay, I disconnected the positive lead from the battery because these would be live. Even though the BMS is not plugged in, there would still be voltage on it, so just disconnect it for now. So 30 amp Andersons, and positive goes on the right, and the lip has to face up. So I crimp these on and then I solder them afterwards. Okay, this is positive. Lip needs to go up, and there's a metal piece in the Anderson insulator that also needs to go on top. And push it until it clicks. Same on the negative side, metal piece on top. Lip needs to go up. And then you can push these into each other. They have a groove, like a tongue and groove. Here you go, that's your Anderson. So now it's insulated, so it's safe to put the positive terminal back on the battery. So now it's time to run the balance leads. So clip your balancing cable into your BMS, and the black wire goes to the main negative, the red wire goes to the main positive, and then you have three other conductors here. They are white. The first one goes to the first positive, the second to the second positive, and the third one goes to the third positive. So the way I do it, I run my negative first, and it only needs to go to this negative terminal here. So I'll cut this wire fairly short, put a ring terminal on it, solder it, and connect it to the main negative. Here we go, crimped and soldered, and then just hook it to your main negative terminal here. My next wire is going to be my main positive because it is the furthest away from the BMS. So I'm determining the length of that wire, and I have to cut all the other conductors to the exact same length to minimize voltage drop across these conductors. At this point you can hook up your main positive, and then you hook up the other wires as they go. So the last step is to use a hot glue gun and run these wires nicely and pin them down a little bit. Okay, here, finished product. I like to label the battery, what the chemistry is and what the capacity is. And I think it turned out pretty well. All right, 2 batteries built. That's all I have for you today, and I'll see you guys on the next one.